Well, greetings, mathletes, and welcome back. Um, so in the last few lectures, what we've looked at are different counting principles, different ways of computing probabilities. What we're going to be taking a look at next is kind of a light treatment of some actual statistics and things like that. A lot of this stuff you may have seen before, may have done this before, and that's fine. I'm noticing the way the book presents it. It's presenting it as if it's not the first time you're seeing it. So we're kind of doing a surface treatment of this stuff, and we will probably also split this into two separate lectures, just because there's a lot of things to hit the light treatment of. So, um, so we're going to start out by talking about the mean, the median, and the mode, and when it's appropriate to use those, and then we'll go into how to construct and interpret a 5-point summary or a box plot. So, without any further ado, let's go ahead and take a look. Okay, so here's the data set. Um, these are I just made these numbers up. They're just random numbers. Well, not truly random since I was the one who made them up. But yeah, in any case, this is our data set, right? And there are 11 numbers here altogether. So yeah, let's go ahead and take a look here. So first off, when we're talking about this, um, all of these are what are called measures of center. Right? And a measure of center, in fact, all of these are called averages, now that we're mentioning it. But the mean, the median, and the mode are the most common ones to use. And just a little bit of warning, there's actually more than one type of mean as well. Sometimes you'll hear about an arithmetic mean or a geometric mean. Those are just different ways of finding a mean, and they don't always come out to the same number, but they are all considered means. Typically in statistics, what we're talking about is the arithmetic mean, and that's the one that you get from adding up all the numbers, right? If um, we have all these numbers in here. It would be, 12 plus 12 plus 14 plus 17. And I'm not, you get the idea, all the way up to plus 31. And then you would divide that by 11 because there's 11 data points. So it's finding the total weight of all your data points together and then dividing by the number of data points you have, right? And this is your typical average. This is how grades are computed and all this kind of stuff. That's pretty typical. And most people are pretty familiar with that. So I'm not going to spend a lot of time on that, but if you have questions, of course, come to me. Now there's also the median. Now the median is the middle number. So it's the middle number when the numbers. Oh, my handwriting's awful. Are placed in order. Okay, so we have a data set up here. The numbers are in order. So we have 11 data points, and so that means that actually, you can do this visually on this one. The data point that is in the middle would be this 19, right? And that's because you can tell, right? If I just go ahead and circle it, you can see there's 5 numbers on each side, and so that is your middle point. So in this case, the median is actually computed not by mathematical computation, but really more by observation, right? And so we have that, which that ends up being 19. Now, then there is the mode. The mode is the most common value. And sometimes you'll hear most frequent value, right? Because you're actually thinking about like frequency tables and things like that. It's the one with the highest frequency. Right? So it's the most frequent value. So looking up here, right, at our, let's see if I can do this without erasing the numbers. almost. Um, but looking up here, let me put that 19 back in. There we go. The value that shows up most frequently, we're looking at these. Well, we have 12 that shows up twice, and we have 19 that shows up twice. Okay, so there's two that have the highest frequency. In this particular case, there's two things you could say. Sometimes these things are called bimodal, right? So you have two most frequent values and they come out to a tie. Sometimes we say there is no mode, right? Okay, so it depends on the situation which one you're going to end up using. For example, with the modes, let's say you are selling men's jeans, right? And you look at all the different waist sizes um, that you're selling, and you see and you look for the mode because that's the one you want to stock up on, right? That's the one that you're selling the most of, and you see that there are two modes. You see that you're selling 34 waist jeans quite a bit, and you're selling 40 waist jeans quite a bit. Well, in a case like that, well, it's good to notice both modes, right? Because both of them can make you money, so that's what you want. However, if you're looking at election results, you want one single mode, right? So that you can have a winner. If not, it's a tie in the election, and that's a problem. So it really just depends on whether it's important to have a single number or it's not important to have a single number, and all of the information is useful. So that changes from situation to situation. Now with the median, and I'm just going to work my way backwards up the list here. One of the reasons that we would use the median is because of the fact that it's not, it's fairly resistant to outliers. Its value doesn't change a whole lot when you have extreme values. I'll give you an example. Okay, so I'm just going to do it this way here. Okay, so here's the example. Let's say I am trying to figure out the average income or the average net worth of students in our class, right? So I gather a sample of 10 students and I take their incomes and I average them, right? I get a number. Um, Now imagine Bill Gates was one of my students. I would absolutely let him bribe me for a grade too, by the way. He has enough to bribe me. Nonetheless, if Bill Gates was a student and he ended up in that sample, the average of that sample would go through the roof. On average, everyone would be millionaires. And that's not very representative. However, if you use the median and you're just looking at the middle value, if I'm just going to do this real quick. Let's say I have 35,000 a year, 25,000 a year, 60,000 a year, and then you have Bill Gates who makes like $1 billion a year. Immediately it goes crazy. But if you're looking at the median, right? Um, and instead of a 60, I had Bill Gates sitting here, the median would still be the same number because it's positional. It has to do with what position it falls in the data. And so if you get an extreme value, that's going to go all the way to one end or all the way to the other end, depending on whether it's an extreme high or an extreme low value. And excuse me. And then ultimately, it just ends up not affecting the median very much. However, if you're averaging things, that entire extreme value is folded into this. And so when you have a situation where you have a lot of outliers or a lot of extreme values, the median is a better choice because it's stable under extreme values. Under almost all other conditions, the mean is a good choice, right? In fact, you can do the most mathematics with the mean itself, being that it is a mathematical operation, and you have things that you can compute with. It really does. It really does lend itself to quite a bit of stuff. In fact, almost all of statistics is based on the arithmetic mean in one way or another. So, okay, so that's kind of the quick review of that. Now, what I want to do next, let's see, how do I want to do this? I'll do it this way. Let's go ahead and erase this. I want to talk about box plots and 5-point summaries. Let me get this off of here too. Okay, so we can just reuse this data. Let's see if I can erase these underlines here. Trying to do it without erasing the numbers. Hey, I guess I do have some skills. They don't hand these degrees out to anybody. Okay, now here's what a 5-point summary is. And the 5-point summary is used directly to make what's called a box plot. And just be aware, sometimes they're called box and whiskers plots. Okay, so a 5-point summary or a 5-number summary consists of, well, you're going to be really surprised, 5 numbers. So the first number that I want is the minimum. The last one I'm going to be collecting is going to be the maximum, right? And actually, those are probably the easiest ones to find. Then we also need the median. And then we need quartiles. Now, quartiles are kind of like medians, but they, instead of a median, breaks it into 2 pieces, breaks your data into 2 equal pieces. Quartiles break it into 4 equal pieces. So we'll talk about how to find those here shortly. So quartile 1 is actually just, we use the symbol Q1, and then we also have the symbol Q3 for quartile 3. Actually, I'm just going to get that off there. Just write Q1 so it doesn't take up so much space. Yeah. Okay, so let's go ahead and go through and find these things now. Now, you have to have your data in order. So it has to be listed from smallest to biggest. Well, I suppose you could list it from biggest to smallest too, but I don't think that would help you much. Let's see here. So we have the minimum and the max, first of all. So the minimum is 12 and the maximum is 31. Okay, now then we have to find our median, right? And we actually did that before. We found that our median was 19. That was the middle number. Okay, now, you know, the median is not, there's not always a single number in the middle, because if you have an even number of data points, like we have 11 right now, so we have an even number, or we have an odd number of data points. So there's a clear middle number. But, you know, you have about a 50% chance of having an even numbered data set. And so if that's the case, what you do is you take the 2 numbers in the middle and you average them. Well, that's what we're going to do with the quartiles in this case. Okay, so to find the first quartile, what you do, since we know this is the median right here, we exclude the median and everything bigger than it. And we just look at this first half of the data right here, right? And what we want to do at this point is find the middle number again. And we have one here, 14. So this is Q1, right? And then, let me write that in. Over here on the right-hand side, when I want Q3, again, I exclude the median. I don't use the median at all. I'm just going to get rid of everything on this end and just look at the top half now. What's the middle number in the top half? And it's 27. And again, if you happen to have an even number when you do this, what you do is you average the 2 middle numbers. So you add them together and divide by 2. Okay, so now that we have this, right, we have our 5 numbers, what we're going to do is mark those on a number line. And so we're going to test my number line drawing ability here. So let's say, we'll do it this way. I'm going to start counting at 10. We'll do 10, 15, 20, 25, 30, and 35. All right, the scale depends on the size of the dot plot, or not dot plot, box plot, excuse me. Okay, so let's start marking these numbers, and I'm going to switch colors here so we can see what I'm writing. Okay, so first I like to mark the minimum and the maximum with a small tick mark. So the minimum's at 12, the maximum is at 31. Okay, and then I mark the other three numbers, right? But I use a bigger tick mark for these. So 19, let's see, that's just less than 20. And then the medians are 14, which was here, and 27, which would be here. And then we just connect our box, right? And so we've just created a box and whiskers plot. I really should have written those other ones in too. Let's do that. 14 and 27. Now, there's some things about these box and whiskers plots. One, I always ask this trick question in class. This divides the data into four regions, right? You have the one between 12 and 14, the one between 14 and 19, the one between 19 and 27, and the one between 27 and 31. Which one has the most data in it? And what's interesting about that, and I don't know, I just asked that question almost expecting someone to answer, but what's interesting about that question is that all four of those spaces have exactly the same amount of data in them. Each one has exactly 2 data points. You can even look, right? 2 data points, 2 data points, 2 data points, 2 data points. You can actually go right back up to the data and take a look at it. So what this is actually showing you is how densely packed the data is, right? So if an area has a smaller width, what you have is the exact same amount of data pressed into a smaller area, right? So it tells you about the density of your data in that particular quartile, or actually quadrant almost. Now, let's talk a little bit about how to use these things. Okay, so let me go ahead. I'm going to get rid of all of this, as a matter of fact. We're going to just look at box plots and see what we can interpret. Okay, so quite often these things are put side by side and or stacked one on top of the other. Sometimes they're organized horizontally, sometimes they're organized vertically, but you can tell some things by looking at them. Oh, let's actually switch this back to, there we go. Okay, so let's just say that's a number line. It's not as liney as I'd like it to be, but I'm just going to throw a couple of box plots on here. Okay. And let's do. Sorry, I'm copying right now. Okay, so you guys are going to be teachers. So let's go ahead and take a look here. Let me throw some numbers on here. So, wow. I was trying to write 41. Here we go. 41, 60, 70, 81, and 90, and 48, 55, 64, 85, and 100. Okay. So with those numbers here, now here's what I want you guys to think about for a second. These are 2 box plots. They're very hastily sketched, but more or less more or less proportional. What I'd like you to do is imagine these are the scores from two of your classes on the same test, and you just want to get a sense of how the two classes are doing compared to each other. Or sometimes what happens is you're comparing the last time you taught a course to what you're doing now, and you want to see how it stacks up. And so it's a good way of comparing two different populations, just to see what might be true about them. So what I'd like you to do here is just go ahead and pause this and then try to jot down as many observations as you can about what's going on with this. Okay, so I'm assuming you've already paused it and jotted everything down. Let's take a look here. So, one of the things you want to be thinking about is which class did better. And there's things you can look at there. For example, you can look at the high score. Which class had the higher high score? Well, this one had a high score of 100, and this one only had a high score of 90. So definitely less A's, or maybe the same number. There could, this 100 could be one score sitting out there all by itself too. You never know. Same thing with this 90. That could be one score. It could be several scores of 90. So it's kind of hard to tell just from the high score. And then you think, well, what about the average? Well, we don't have a mean here, but we do have the medians, and we can take a look at those. And we see that this median is 7, and this median is 60 or 70, and this one is 64. So if we're looking at the high score, this class did better, right? We'll call this class A and class B. That way we can talk about them a little bit easier. If I look at high scores, class A did better. If I look at the median, though, which is more of a representation of the average, class B did better. Now, there's other things you can look at here. For example, looking at the third quartile. What this means, by looking at this 85 right here means that class A, 75%, 3/4, right? Because remember, each one of these sections is a quarter. 3/4 of the class scored an 85 or lower. 1/4 of the class scored 85 or higher. So now we're looking at where 3/4 of the class went, right? That's a fairly big bulk. 3/4 of the class scored 85 or lower. Here, 3/4 of the class scored 81 or lower. If we look here, half of the class scored 70 or lower, or 70 or higher. Here, half of the class scored 64 or lower. So in this case, there's actually not a clear representation of which class is doing better. It depends on what you're looking for. If you're trying to bring up the class average, well, class B did better. If you're trying to get the most people passing, think about that. So a D or higher. Well, here, 3/4 of class B had a D or higher, right? But over here, that same mark, 3/4 of the class, that same 3/4 of the class scored 55% or higher here. So this one has a higher minimum, so to speak. So there's a lot of different interpretations that you can use as you go through these. Excuse me. And there's not always a one correct answer. It really depends on what you're trying to get out of the stats. What you really want to remember is that all of these things are just to be able to pull information out of the data easier. It's very difficult to pull information out of a spreadsheet unless you summarize the spreadsheet somehow. And so what we've seen today are different ways of summarizing data, right? We can summarize data with a single point, right? Which is our averages, our mean, our median, and our mode. Or we can summarize averages using a box and whiskers plot or a box plot. And what that does is it marks the center, but it also gives you an idea of how spread out the data is and in what ways it's spread out, which areas are spread out more. So all of those things are useful to inform you about the data. And in any case, that's where we're going to end here. Now, we still have more to talk about in this section, but that's what we're going to cover today. And so until next time, keep your pencils and your wits sharp.